So this is Math 2, Lesson 913. And before doing this lesson, make sure you know how to graph by hand. There is a graph by hand lesson. Make sure you do that first. We will graph by hand in person, but it's important to practice. It's important to understand. It's much harder to do this lesson without that in your tool bag. So Anissa's looking over her work from Parabola Lab, which was our Desmos activity, where we were doing the student.desmos activity. She wrote down the equation g of x equals x minus 3 quantity squared minus 4, but she cannot find the graph that goes with it. Based on what we've discovered in the Parabola lab, let's go ahead and sketch the graph of g of x. So what we know is, first it wants to do how is it transformed. So I'm going to start actually by just graphing f of x, which is x squared. So my vertex is at 0, 0. I go 1 over, 1 up, 2 over, up 4, 3 over would be up 9. It looks like I have enough room for that. This is going up to 10. Then 1 over to the right, left, and up 1, 2 to the left, and up 4. From the vertex, 3 to the left, and up 9. Again from the vertex. The other way to think of it is 3 to the right and up to the, and this one to 9. Okay, there's my pretty, that's my original. That's f of x, which is x squared. I'm going to go ahead and write f of x, which is x squared. And I use the light color so that it wouldn't detract from the next one. So I am going to do g, and so the graph of this one is at 0, 0. So that's the answer to that. And the graph of g is the vertex of g of x is at 3, negative 4. So 3, negative 4. And then other than that, it's going to be the same thing. So we're going to go 1 and 1, 2 and 4, 3 and 9, 1 and negative 1 and positive 1, negative 2 and positive 4, negative 3 and 9. That's too many. Lovely. 9. Okay. And so there's my pretty graph. Okay, so there's my pretty graph. And that's g of x. All right, determine the x-intercepts and y-intercept from the parabola. So x-intercepts are 1 and 5, or 1, 0, and 5, 0. Do not, crap, I'm not recording at all. Oh, yes, I am, sorry. Oops. I'm tired. Okay. Do not write. I want my do not color. This is going to be my do not color. Do not, is that pink? No, that's the red one, okay. Do not write 1, 5 like so. That's not okay. All right. And so there's that. All right, so that's the x-intercepts, either as a list or as ordered pairs, not as an ordered pair themselves. Then my y-intercept, list it's 5, or I can write 0, 5. Okay, no big deal. I'm just reading. So there's no work to show. I'm just going to go look at the picture. I don't know how to show my work for this. That's kind of a weird statement. Rewrite Anissa's equation in standard form and factored form. So I'm actually going to do factored form first. So factored form, I'm going to use my factors here. And I have x minus 1 times x minus 5, if you recall. And that is g of x. Now to rewrite it in standard form, I'll do that over here. I'm going to start with x minus 3 squared minus 4, x minus 3. I'm going to write it down twice so I don't make a mistake. Then minus 4. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And so x squared minus 6x plus 9 minus 4. So x squared minus 6x plus 5 is g of x. Okay, so that's how I would convert it into standard form. Okay, and it would have been easier to go from factor form back to standard form, but I would want to show you that then when I factor this, I get back to that. Two numbers that multiply by positive 5 but add to make negative 6 are negative 1 and negative 5. All right. Sketch the graph using the information in factor form. At this point, I would just double check with decimals that they are all the same. I want you to do that on your own. They are, I promise, but double check that. So we're going to skip 4. So, number 5, a function in the form of blah is said to be in fact graphing form with a locator point of h, comma k. So let me read this out loud. F of x equals a times x minus h quantity squared plus k. Where h and k are the locator point. In this case, h and k are the vertex. Notice that the formula does say minus for h and plus for k. Okay? Meaning that the sign of h will change from the equation and k will not change from the equation. Okay? Why is this name appropriate? Because the vertex is easy to identify. Okay, moving on. Let me move this down. In problem 23, we rewrote an ACES function from graphing form into standard. How do we reverse it? So I don't know if you recall, but I'm going to just start. We actually don't need to reverse this. We know it's exactly the same equation as the one we were dealing with previously. And so I would go like this. This is how I would do it. And again, I'm not trying to do it. I'm just trying to spur something in your brain. So what do you think we're going to do? It's 2 words. We are going to complete the square. Okay. So we've completed the square before. We know how to do it. That's where my swivel comes in. I'm not asking you to do it here. I'm just reminding us. In chapter 5, we use the process of completing the square to rewrite quadratic equations in what we call perfect square form, which is also graphing form. For example, by completing the square, we would rewrite x squared plus 4x minus plus 1 equals 0 in perfect square form as x plus 2 quantity squared is equal to 3. The process of completing the square can also be used to write everything in graphing form. So let's try it. Rewrite each equation in graphing form. So what I do first is I need to find out what squiggle is. I need to take half of 6 and square it. So 6 divided by 2 is 3, and 3 squared is 9. Oh, that's that number. I don't need to do a squiggle on this. So f of x is equal to x plus 3 squared. Because then I think, okay, so what? I'd use that half number, it goes there, that's my quantity squared. And this time my squiggle was nothing. So let's go ahead and take a look at this one. We will do the same math, and I will set this up in a way that will help you later. So they like to move the one first. That's what we would have done when we were doing getting it so we could solve. We would have moved it over. I don't love this moving over. It feels kind of like too much work, and I don't like the way it looks, but I'm doing it to just be consistent. I will have a squiggle here and a squiggle there. I've already figured out what squiggle is, because it's half of 6, and square it. So squiggle is plus 9 on both sides. Whereas if I'm doing it here, like I was putting it back here, this would be plus 9, and this would be take away 9, so that I'm adding 0. Okay, so we're actually probably going to do it here more than we're going to do it here. But anyway, so we get g of x plus 8 equals x squared equals x plus 3 quantity squared. And then we subtract 8, which is why I think it's kind of a useless thing to move the 1, because I just have to put it back in the end. But it does make it easier to be adding the same thing to both sides rather than trying to add 0. So it's just a question of which one you want to do. So let's go ahead and see what we can come up with to do these next set of problems to complete the square on. I'm going to do B and let you do A by yourself. I will also do J and let you do D by yourself. A and D are much easier than B and C. So for B, I'm going to cut in half. Need to figure out squiggle. And again, I'm not going to move my number because then I just eventually have to move it back. So I'm going to take half of -3, which gives me -3 divided by 2. Then I'm going to square that, which is 9 over 4. So I'm going to add 9 over 4 and subtract 9 over 4. Now we don't like this because we're not comfortable with fractions. You're welcome to use decimals. I don't like to use decimals. They make it harder for me. So I'm going to use fractions. This becomes x minus 3 over 2 quantity squared. That was the whole point. Okay, this is -5 minus 9/4. So -5 is -20 over 4 minus 9/4, making this -29 over 4. And that, I'm finished. That's my answer. And again, you are welcome to use decimals instead. It tends to be 0.5 and 0.25 as your final answers. I just don't like to. It makes it harder for me. I make more mistakes with decimals than I do with fractions, so I prefer fractions. All right, part C. So to deal with part C, I can't have any number but 1 in front. So I'm going to go ahead and pull out 2, but only from the first 2 terms. Then I'll have squiggle plus 29 and squiggle. So the number I'm going to get here is I'm going to take 8, cut it in half, which gives me 4, and then I'm going to square my result, which gives me 16. So this is 16. Now here's the trick. I've added 16 twice. Not just 16 once, I've added 16 twice because of this 2 out here. So this needs to be taking away 16 twice, or minus 32. Okay, taking away 16 twice. Okay. This becomes 2 parentheses x plus 4 quantity squared minus 29, take away 32, is -3. And there's my equation. But that doubling is really, really, really critical. Okay, that doubling right there is where we make the most mistakes. On D, I might take that -x right out first and move it to the other side. So then I change all the signs to make that easier. So go ahead, see what you can come up with. Ta-da! Different paper, different work. But so this becomes k plus 4 was already done. Half of 8 is 4. 4 squared is 16. Right from there, just stole it, and then I just minus it back. This one, half of 4 is 2. 2 squared is 4. x minus 4. It's right there. Okay. Straightforward. All right, we're going to use that to help us in the next problem. Part C says that we need to draw some graphs. So I'm going to have this here in case I need it, but I'm drawing graphs for part C. Sketch the graph parts A through D. And so A will be this color. A is x minus 2 quantity squared minus 1. So, and it was f of x. Let me do that. I will also label it as f of x or A. I'll probably do f of x. So, my vertex is at positive 2, negative 1. 1 away up 1, 1 away up 1, 2 away up 4 from the vertex, 2 away up 4, 3 away up 9, so that's 4, then 5 more. Okay, so there's that. B. B is g of x equals parentheses x minus 3 divided by 2 squared minus 29 over 4. So that's 1.5 and 7.25, negative 7.25. So 1.5 and 7, 6, 7 and a quarter. So this one's actually really hard to do with the pattern. The pattern falls apart because my vertex is not nice. But I'm going to give you a hint that goes through those 2 points. Almost without fail. 2 points right next to it. And then it gets a little bit funky. And I can't remember. So if I plug 1 in to this, I get negative half. Half squared is 1/4 minus 28, which is 7. And that's what happens. So that's why those are both 7. If I plug 0 in, I get 9 over 4. So that's 20. Negative 20 over 4, so that's 5. 5. So right there. So I'm plugging in numbers and using symmetry to help me, but that's enough. I'm just going to stop right here. It is the same graph. It's just funky, but it is that graph shifted down. That will be g of x. Okay. Next, hopefully C is 2 parentheses x plus 4 squared minus 3. So my vertex is at negative 4, negative 3. And now I have this 2. So it's a stretch factor of 2. Up 1, right 1, up 2. Right 2, up 4, or 4 twice. 1 twice, 4 twice. And that is equal to, I forgot, j of x. Okay. And last, but most certainly not least, is we're going to use a red. We're going to use red. Have red. D, which is k of x, equals negative x plus 4 squared. So my vertex is at negative 4, 0, and it's opening downward. And that is k of x. There you go. And it'll take you a while. It's okay to get that right. So Anissa is asked to rewrite the function 2x squared minus 12x minus 23 in graphing form. Her number steps are shown below. She knows she's made a mistake because when she graphed the original and her answer, they don't match. So something is wrong. Where did she go wrong? I'm ready to click select correct solution. So when we talk about where she went wrong in steps like this, we're looking for the first step that is wrong, that is not equivalent to the line above. One easy way to find it is to actually type this into decimals and see when it stops matching. It's on line 4. So line 4 is her error. And it happens to be because of this. So yes, we add 9. Negative 2 times. So really, I've subtracted 18 over here. If I distribute this 2, it's actually negative 18 on this side. So this needs to be 18, not 9. And it needs to be negative. And that's really weird. Which makes this, from this line, it will now be, so g of x plus 23 minus 18, which will be g of x plus 5 equals negative 2 parentheses x plus 3 quantity squared. So g of x is equal to negative 2 parentheses x plus 3 quantity squared minus 5. And we'll just look at decimals and make sure we're right about those two, and we'll be finished. Decimals. And our original was negative 2x squared minus 12x minus 23. And my new one, negative 2 parentheses x plus 3 quantity squared minus 5. So I did it right. Easy way to check. Very, very, very easy way to check. Okay? And that's that. I hope you have a great day. See you guys soon.